Alright, so we're going to graph sine functions today, and tomorrow Friday we'll be graphing cosine functions. They're basically the same technique. The only difference is step 4 is different. So if you, by some reason, aren't going to be here on Friday, my guess is you can probably watch the video and understand everything there is to know about it if you understand today well. So hopefully, if anybody fits that description, we'll be fine. So anyway, the two things we're going to focus on today are amplitude and period. The sine graph itself, we just take a look at a basic sine graph, y equals sine of x. And we're going to be graphing in radians, so just to be consistent all the way through, graphing in radians. The normal sine graph starts at 0, goes to pi over 2, pi, 3 pi over 2, and 2 pi to make one full period. So it starts at 0, and it goes up 1 and down -1. That's normal sine graph. And sine of 0 is 0, and sine of pi over 2 is positive 1, and sine of pi is 0, sine of 3 pi over 2 is negative 1, sine of 2 pi is 0, and it goes up and down and up like that. And it continues on forever and ever and ever. It just keeps on repeating that same thing again and again and again. All right? That's what sine is. And again, if I were to extend this further along, so 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, it would hit the top, 0, bottom, 0 again. So it just keeps repeating itself. It's a periodic function. It repeats itself again and again and again. The normal amplitude of sine is 1. So amplitude is how high it goes above or below the center line. And the normal period of sine is 2 pi. So that's normal. All right? So we go back here and we see amplitude and period involve these letters B and C, which I haven't discussed yet. If we can imagine y is equal to b sine of cx. Okay, that's what we're going to be looking at, that structure today. And lesson 5.7, I think, chapter 5.7, I think they throw in an A and a D also. A moves it up or down, so you already have your sine graph created. A moves it up or down, and D moves it left or right. All right, we're going to deal with those in another chapter. But right now, we're just going to make them stretch or shrink, and we're going to make them stretch or shrink. So horizontally, vertically stretch or shrink. Let me just say that every graph you make following this procedure will look pretty much the same. All right, but I want you to see the differences in the three graphs we do today. After we graph all three of them, I'm going to show you what all three look like on the same window, to show you that one shrunk from the other. One's happens more often, one's like really wide and stuff. So you'll see that. But anyway, structure we're looking for, some number times sine of some number x. That's the structure we're looking at here. The number in front of the sine function is the amplitude number. The absolute value of that number is the amplitude. So if it says 5 sine of x, instead of going up to 1, it's going to go up to 5. If it says 0.2 sine of x, instead of going up to 1, it's going to go up to 0.2. So it's going to shrink it or make it raise. All right? The number in front of x divided into 2 pi gets us the period. So 2 pi is normally the period. So if we're doing sine of 1x, 2 pi over 1 is 2 pi, the normal period. If c is bigger than 1, 2 pi divided by that number is going to happen more often. And if it's less than 1, 2 pi divided by a number less than 1 makes it bigger, so it happens less often. So if the number's big, a lot more things. If the number's small, a lot more flowing. All right? All we're going to do here, draw the x-axis and y-axis to the far left side of the x-axis. So to start off there every single time, and I've already started you on your papers, but make it look like that. All right? Put 4 dashes equally spaced, 1, 2, 3, 4. You don't have to get a ruler out, kind of eyeball it, equally spaced. And 1 dash above and below the x-axis for the y-axis. I think I might have given you a couple more dashes on your paper, but I just need 1. Then you need to label the dashes. Now labeling the dashes comes from these things here. So if I know what the period is, and I know what the amplitude is, amplitude tells me how far to go up and down, and period tells me what this is. And then I got to cut it into fourths. So divide the period by 4, that's how much you go up for each dash. Then one of two things is going to happen. B is either greater than or less than 0, the original B, this one here, before we did the absolute value. All right? If B is positive, the order is the normal order of sign. And the normal order of sign is 0 top, 0 bottom, 0. That's the normal. Okay. 0 top, 0 bottom, 0. If B is less than 0, the order is going to be 0 bottom, 0 top, 0. Ended up at 0. Okay. So those are the things. And then once you get your 5 dots, connect the dots with a smooth curve. And your graphs are always going to look like that. They're either going to be like this, or if it goes down first, it'll look like that. All right? So, let's try it out. Here we go. Go far enough over, you find the top. All right. Y equals -2 sine x. So what I see right off the bat is that B's value is equal to -2, C's value is equal to +1. Always start off there, identify the values of B and C, because that'll help us establish the things we need to find for the sake of graphing this sine function. The absolute value of B is the amplitude. So amplitude is going to equal +2. The period is always 2 pi divided by C, so 2 pi. Okay. I have my x-axis and my y-axis graphed, and I'm probably going to put an x here and a y here just to have good form on my graphing. We always label our x and y axes. I'm going to put a dash up and a dash down about equally spaced from the center, and 1, 2, 3, 4 dashes about equally spaced. Again, I'm not going to count off. If you try getting them equally spaced, let me show you what bad would be. You didn't try very hard, okay? Make them look kind of equally spaced. I'm not going to be too upset about it, but you know, give it a good shot. All right. So my amplitude tells me how far to go up and down. So this is 0, 0 right now because we're not moving up or down or left or right. We're just stretching or shrinking, and we're stretching or shrinking. So 0, 0 is going to be a point in every one of our graphs. So I'm going up 2 spaces and down 2 spaces because the amplitude is 2. The period's 2 pi, which means I'm starting at 0. I'm going to end, my 4th dash is 2 pi. And there's 4 dashes, so I'm going to go up by fourths. So if I do 2 pi over 4, which equals pi over 2, that's how much I'm going up by. So 0 plus pi over 2 is pi over 2. Pi over 2 plus pi over 2 is 2 pi over 2, better known as pi. 2 pi over 2 plus pi over 2 is 3 pi over 2. 3 pi over 2 plus 2 pi over 2 is 4 pi over 2, better known as 2 pi. So again, if you just take whatever the period is and divide it by 4, that's the amount we're stepping up by on each dash on the x-axis. All right? Final thing, we have 2 possibilities. B is greater than 0, and B is less than 0. Little mnemonic device for you. Greater than 0, otobo. Less than 0, oboto. It's easier remembering 5 words, right? So, otobo, 0 top, 0 bottom, 0. Oboto, 0 bottom, 0 top, 0. I can see B's original value is -2, which puts it less than 0, which means I'm going to go with that. 0 means middle. B means bottom, so we go where the bottom dash is. 0 means middle. T means top, where the top dash is. And 0 means middle. So 0 bottom, 0 top, 0. Connect the dots with a smooth curve. And there's our graph. If I were to go to my calculator and type this in, we've got all 3 typed in right now, but let me just turn these 2 off. All right, I'm going to set my window the same as what I have there. So x is starting at 0, ending at 2 pi. We're going up at a pi over 2 scale. And the min and max are -2 and +2, right? With a scale of 1, or a scale of 2, I guess. Hit graph, and you should see exactly the same picture on your calculator screen that we have on our paper. And each time we graph these, we're graphing them on his window. We're setting the window by going up and down the right amount, going left and right the right amount. So again, every graph's going to pretty much look like that, either that or the upside down version of that. On the calculator screen, if we set the window the same, we'll get the same results. Okay? And I want you to get accustomed to that. But at the end, again, when I do example 3, I'm going to graph example 3 by itself, and I'll put the other two graphs on there too, so you can get an idea of how they relate to each other.